Greetings, AP Chemistry students. Today we're going to learn about percent composition and empirical formulas. This is something that you should have already seen before, but I'm going to go over it with you again because, for some of you it's been a while since you've had a chemistry class. So, percent composition is the percent by mass of each element in a compound. So, for instance, even though water is two hydrogens and one oxygen, since hydrogen has a mass of just 1 gram per mole and oxygen has a mass of 16 grams per mole, oxygen is going to have a much higher percent by mass, even though it only makes up one out of every three atoms, because each oxygen atom is 16 times as heavy as a hydrogen atom. So to calculate percent composition, you first need to find the molar mass of the compound, so you add up the mass of everything in there. Then you figure out essentially how much the total of that one element weighs. So figure out how much hydrogen there is in water by adding up the mass of each of the two hydrogen atoms. Divide that by the total molar mass and multiply it by 100 to make it a percent. So as an example, if we want to determine the percent composition of water, first we figure out that water has a molar mass of 18.02 grams per mole. Then there's two hydrogens that are each at 1.01 grams per mole, so that's 2.02. The mass of oxygen is 16. So then the percent hydrogen, we take the mass of hydrogen in water divided by the total mass of water times 100. It's 11.21%. Oxygen, it comes out to be 88.79%. And hopefully when you add those percents up, it equals 100%. And if you've done it right, it will. Empirical formula is the opposite. You're taking percents and you're turning them back into chemical formulas. Now, empirical formula is technically just the simplest ratio. And that's because if we take a look at a couple of compounds, for instance, there is CH2O, there is C2H4O2, and then there's C6H12O6. Well, this is glucose. This is vinegar or acetic acid, because if I rewrite it as HC2H3O2, you can see that's the same thing. It's 4 hydrogens. And this is formaldehyde. These are very different compounds, but they all have the same 1 carbon to 2 hydrogens to 1 oxygen ratio. And so they would all have the same percent composition. If you calculated percent composition, it would all be the same for these. So if you're starting with percent composition and you work backwards, you're always going to come up with the simplest ratio, which is that one. That is the empirical formula. It's the simplest ratio. Instead of a 6 to 12 to 6 ratio, it's the 1 to 2 to 1. Now, there is a distinguishing factor between these three things, which is that they would have very different molar masses. And we'll talk about that in just a bit. So, with empirical formula, the way you calculate it, the first thing you do is kind of a thought experiment. You pretend that you have 100 grams of your compound so that all of those percents are essentially grams. Then, based off of the percent composition, you find the mass of each element. You convert those grams into moles using the molar masses on your periodic table. You then divide by the smallest number of moles. And then if you end up with some fractional values, you'll multiply out to get whole numbers. So I'm going to work through some examples with you. So if a compound is 40.05% sulfur and 59.95% oxygen, if there's 100 grams of this compound, you have 40.05 grams of sulfur and 59.95 grams of oxygen. And then if we convert those into moles by dividing by the molar mass, it's a one-step mole conversion for each of these. You get the 1.249 moles of sulfur, 3.747 moles of oxygen. Then you divide those by whichever one of these is the smallest, which will convert these into whole number values, 1 and 3. That's 1 sulfur, 3 oxygens, so it's SO3, sulfur trioxide. I have another example. If we have a compound that is 48.64% carbon, let's see, it is 8.16% hydrogen, and it is 43.20% oxygen. The first step is if we have 100 grams, then these percentages will magically become grams. So we're going to convert grams into moles, where 1 mole of carbon is 12.01 grams, where 1 mole of hydrogen is 1.008 grams, and 1 mole of oxygen is 16.00 grams. So we pull out our trusty calculator, and 48.64 divided by 12.01 is 4.05. 8.16 divided by 1.008 is 8.10. And 43.20 divided by 16 is 2.7. These are all moles. So now we divide everything by the smallest number of moles, which is 2.7. So we take everything divided by 2.7. So 4.05 divided by 2.7 is 1.5. And 8.1 divided by 2.7 is 3. So this is a case where our empirical formula looks like it's C1.5 H3O. Well, you can't have fractions. You can't have a half or a third or a quarter of an atom. So we need to multiply everything by 2 to get rid of that decimal there, make it whole numbers. So that becomes C3H6O. So anytime you have something that is approximately like 0.25 or 0.75, that's like a fourth or 3/4, you would multiply by 4. If you have 0.5, you would multiply by 2. If you got something like 0.33 or 0.66, that's like a third or 2/3, then you would multiply by 3 to get rid of that repeating decimal fraction. Right? So C3H6O would be the empirical formula. I'm sorry, O2. I don't know what I was thinking. I forgot to multiply by 2. Sorry about that. C3H6O2. Now, molecular formula is just one extra step we add on to the end. If you have the empirical formula and you also know the experimentally determined molar mass of the compound, then you can figure out what the actual molecular formula of the compound is. We'll learn several different ways to determine molar masses of compounds in this class. But for today, don't worry about how we figure that out. But if you knew the molar mass and the empirical formula, you can figure out what the actual formula of the compound is. By taking the actual molar mass that you're given and dividing it by the molar mass of the empirical formula, you'll come up with some integer value. It'll either be the same, or it'll be the actual molar mass will be 2 or 3 or 4 or 5 or 6 or 7 or some multiple of the empirical formula's mass. So you just multiply all the subscripts by that. So I'll walk you through an example. So maleic acid has this percent composition. So it is 41.39% carbon, 3.47% hydrogen, and 55.14% oxygen. And the molar mass is 116.1 grams per mole. So we start the same way. We convert our grams into moles. This is 1.008. And 1 mole is 16 grams. So we take 41.39 divided by 12.01, and we get 3.45. 3.47 divided by 1.008 is 3.44. And 55.14 divided by 16 is 3.45. So you can see these are all the same. So if we divide them by the smallest, the 3.44, we get approximately 1, 1, and 1. So our empirical formula is just CHO. Now it has a mass of 12.01 plus 1.008 plus 16. Its mass is 29. We were told that the actual mass is 116.1. So if we take 116.1 divided by 29, we get 4. So this is our empirical formula. Our molecular formula is going to be 4 times that, or C4H4O4. So that is our molecular formula. All right. I hope that answers your questions.